Welcome to the deep dive. Today, we're looking closely at a scientific framework combining ketosis and a caloric deficit. You shared some really fascinating sources, and, well, our mission here is to pull out the key insights, the surprising facts,
hmm
basically give you a shortcut to understanding this approach and how it actually works. So let's dive straight in with maybe a big idea. This surprising hierarchy of macronutrients. We usually hear they're all equally important, but the science here suggests something quite different, doesn't it?
It really does. It's about understanding biochemical essentiality. So when we say essential, we mean things your body can't make itself. It has to get them from food. Like proteins have 9 essential amino acids. Fats have 2 essential fatty acids. We absolutely need those from our diet.
Okay. Essential means we can't make it.
Exactly. But here's the kicker. Carbohydrates are not essential by that definition.
Yeah.
Your liver, it's amazing. It can actually make all the glucose your body needs through gluconeogenesis, even if you eat 0 carbs. It's a fundamental shift in thinking about fuel.
That's huge. Especially, everyone talks about the brain needing glucose, right? Being a glucose hog.
Hmm.
If the body makes its own, what happens with the brain's energy supply then?
Great question. And that's where physiological ketosis comes in. This isn't some dangerous state. It's normal, safe, tightly regulated. We're talking blood ketones, maybe zero point 0.5 to 3.00 millimoles per liter.
Right, not like diabetic ketoacidosis.
Not at all.
Oh.
Way higher, over 20, and involves an insulin crisis. Physiological ketosis is different. And ketones, they're actually a kind of super fuel for the brain. They can supply maybe 60, even 75% of its energy, and more efficiently than glucose.
More efficiently, how so?
Well, they produce more ATP, that's the energy currency, per unit of oxygen, and crucially, fewer reactive oxygen species. Less of that cellular exhaust that contributes to aging.
Okay, so a cleaner, efficient fuel, that's really interesting. And the other part of this strategy, strategic scarcity, a caloric deficit. Sounds tough.
Yeah, but it's not about starvation. It's a moderate deficit, maybe 10 to 20% fewer calories than you burn. Think of it as a signal. It tells your body to activate some powerful programs for housekeeping.
Housekeeping.
Like autophagy, literally self-eating. Your cells clean out old, damaged parts. It's quality control. And research, like the Longo Protocol studies, suggests it can trigger stem cell regeneration, even rejuvenate the immune system. Old cells get cleared out, new ones grow, like a reset.
A metabolic reset. I like that. Now, something people worry about with keto is protein. This idea that eating too much protein knocks you out of ketosis. Is that a real concern?
That's a really common myth tied to gluconeogenesis. The fear is protein just turns straight into sugar. But the process is demand-driven, not substrate-driven. Your body only makes glucose from protein if it genuinely needs it.
So it's not automatic.
Right? Like a 50-gram protein meal might only result in maybe 2 grams of new glucose, if that. Protein is actually vital. It helps preserve lean muscle mass, which keeps your metabolism humming, and it helps you feel full. Generally, 1.0 to 1.5 grams per kilogram of body weight per day is a good target.
Okay, so protein is a friend, not a foe here.
Yeah.
But how do you actually figure out the calorie part? Those online calculators seem iffy.
They can be a starting point, yeah, but definitely not the final word. For estimating your resting metabolic rate, the Mifflin-Sigler equation is generally considered more accurate these days, maybe 70–82% accuracy, better than older ones. But honestly, the best calculator is your own body's response, meaning you have to track, measure, see how you respond. It takes some trial and error, some iterative adjustments based on real results, how you feel, your energy, your weight trends. It's personal.
Right, personalization. So practically speaking, what should you eat and how do you tailor it?
Focus on real, nutrient-dense whole foods. That's key. High-quality proteins, think fatty fish, eggs, grass-fed meats, healthy fats, avocado, olive oil, nuts, seeds, and lots of low-net carb vegetables. Spinach, cauliflower, broccoli, greens, things under 5 grams net carbs per serving.
And tailoring it.
Yeah, personalization matters. Women might need a slightly more moderate approach sometimes because of hormones. Older adults might benefit from slightly higher protein to fight muscle loss, sarcopenia. And of course, your activity level changes everything. More active means needing more fuel. And crucially, monitoring is important. Check blood ketones, aim for that 0.5 to 3.0 range. Maybe track glucose too. Consider advanced lipid panels like LDL particle number or ApoB for a better cardiovascular picture than standard cholesterol. And please talk to a qualified healthcare professional before starting something like this, especially if you're on medications for diabetes or blood pressure. Adjustments will likely be needed.
Good point. Safety first.
Absolutely. Oh, and manage your electrolytes, sodium, potassium, magnesium, proactively. It helps avoid that initial keto flu.
Okay, so wrapping up, this framework, leveraging ketosis and a mild deficit, it seems to have real scientifically grounded potential, doesn't it, for metabolic health, maybe even tackling chronic issues. It really makes you think. By understanding these deep principles of your own metabolism, fuel use, scarcity signals, nutrient needs, what kind of health, what vitality could your unique system unlock? Something definitely worth considering.